everyone, this is Sheetal and today I'll be talking about Codex Beverage Price Prediction Project. First is project objective. Here we'll build a machine learning model to predict the price range a user would choose for a beverage based on their demographic profile, consumption habits, brand preferences and purchase behavior. So the success criteria here is high accuracy F1 score and the performance, where the model should be able to predict the target as quickly as possible. These are the steps that have been performed for predictive modeling. The provided dataset contains around 30,000 rows and 17 columns. Here the target column is price range, which has around 4 classes, and next step is pre-processing, where we'll be handling the missing values, detecting the outliers and the removal of the duplicates. Next, after this, we'll analyze the features present in the dataset and try to derive a new features out of those existing features to make the model predict the target even more accurately. And next is the feature encoding, that is train, test, split. Before the training, we'll be encoding the categorical features, where for two class features we use one hot encoding and for multivariate we'll use ordinal encoding. Next, we'll split the data into train and the test, 75% and 25% respectively. After that, we'll be training the model. Here we have gone through Gaussian naive Bayes, SVM, logistic regression, random forest, XGBoost and light GBM. Then we'll perform the model fine tuning to find out which parameter will be the best. And the next last step is evaluation. Here we'll be going through the classification report. The dataset contains of 21 columns, out of which the 17 columns are original columns and the other 4 are the derived columns, which were derived from the original columns. So the first one is respondent ID, next is age of the respondent, gender of the respondent, geographic zone of the respondent, respondent's occupation, annual income level of the respondent, frequency consumption of the drink by the respondent per week, the current drink brand the respondent consumes, the quantity consumed by the respondent. Next is the respondent's awareness of the brand measured on the scale, the reason why respondent chooses the specific brand, the respondent's flavor preference for drink, preferred channel for the purchase, respondents' packaging preferences, respondents' level of health concern in relation to drink, consumption of the drink by the respondent according to the typical situation, price range of the drink. Next are derived features. Age group categorizes the age into the groups. CFAB score, which is the combination of the consume frequency and awareness brand score, which equals to the frequency score divided by awareness score plus frequency score. And next is zone affluence score, that is ZAS. This equals to the zone score into income score. Next is BSI, that is brand switching indicator, where if the current brand is not equal to established and the reasons for choosing brands is either price or quality, then it is 1, otherwise it's 0. Here the 1 indicates potential for brand switching. So here we are looking at the accuracy comparison graph, where we can see the Gaussian naive Bayes has the lowest, that is around 0.58, and light GBM and XGBoost has the highest, that is around 0.93 and 0.93 itself, followed by random forest, SVM regression, logistic regression having 0.92, 0.82 and 0.8 respectively. And the F1 score comparison, here also we can see that the naive Bayes has the lowest, that is around 0.4, highest is light GBM and XGBoost, that is 0.92, followed by random forest, SVM logistic regression. So that now we can see that XGBoost satisfies all the success criteria. We'll be going forward with the XGBoost for our prediction. Here we can see the chart of the feature importance of XGBoost. We can see that ZAS score has the highest, that is around 0.22, followed by income levels, health concern, etc. And the lowest is occupation, which has around almost 0. Next step is model fine tuning. We have used a randomized CV for finding the best hyperparameter values. Here we can see that n estimators has around 443, max depth is 6, learning rate is 0.44, subsample is 0.79, coal sample by tree has 0.52, gamma is 0.21, regression alpha is 212, regression lambda 2.84, use label encoder is set to false, eval metric is log loss. For the evaluation, we can see the classification report of the XGBoost. Here, precision recall F1 score for the class 0, 1, 2, 3 is present. Accuracy is around 0.93, macro average is around 0.92, weighted average is around 0.93. So yeah, next we'll see the demo of the application which I have deployed in the Streamlit. Here you can see in the application there are sections, that is personal information, consumption habits and preferences. We'll set the values. Here we'll set the income level as 16 to 25, urban, female 3 to 4 times, 0 to 2 times, awareness is 0, price, availability small. Will set the flavor as exotic, 2 and active online. So let's see, the prediction is 150 to 200. So this is how can you can make use of the application. So if you have any questions, please feel free to comment, and I have also mentioned the GitHub link in the comment section. Thank you.